Greetings, geometry or Algebra 2 students. This is Dr. Heron talking to you about 3.2, talking about systems of equations in three variables. So previously we have spent a lot of time in algebra and a little bit in geometry talking about solving systems with two variables, an x and a y. So now we're going to up the game to three variables. So let's take a look at this problem. In the 2004 Summer Olympics in Athens, Greece, the United States won 103 medals. They won 6 more gold medals than bronze and 10 more silver medals than bronze. Write a system of linear equations that could be used to determine how many of each type of medal the U.S. Olympians won. So if I go back through and look at that information, okay, I notice that all three medals together, gold plus silver plus bronze equals 103, okay? They won 6 more gold medals than bronze and 10 more silver medals than bronze. So if you notice, the gold and the silver feed off of the bronze. And what I mean when I say that is gold is in relation to bronze. So gold is going to be equal to the number of bronze plus 6, and silver is going to be equal to the number of bronze plus 10. Okay, so to solve this, I can do kind of a big version of substitution. Okay, so what I can do is rewrite this, but instead of gold, I'm going to write B plus 6. And instead of silver, I'm going to write B plus 10 plus the actual number of bronze medals, and all that's going to equal 103. Okay, so that's going to be 3B plus 16 equals 103. So 3B is going to equal 103 minus 16, which will be 87, divided by 3 divided by 3. So bronze number is going to equal 29. So if bronze equals 29, gold is going to be bronze plus 6, so 35. Silver is going to be bronze plus 10, so that's going to be 39. Okay? So now, how do I start handling this? When I've got three variables, three equations, what do I want to do? Well, I need to start with the idea of whittling this down to two variable and basically two variables and two equations to kind of work it down. So what I'm noticing though is like there's a 2x on both of these. So I actually want to multiply this top one times a negative 2. Okay? So what is that going to give me? That's going to give me negative 2x minus 4y minus 2z equaling negative 20. I'm sorry if that doesn't come in very well. All right? So I'll rewrite it down here. Negative 2x minus 4y minus 2z equaling negative 20. So what I'm going to do is I'm going to take two at a time, okay? So I've got this top one, which I'll call A, middle one I'll call B, bottom one I'll call C. So I'm going to take A and B and I'm going to eliminate one of those. I'm going to eliminate the x's basically because I've got this situation where I've got a minus 2x and a plus 2x. So that's going to go away. So this is going to become minus 5y plus z equals negative 25. Okay, so now I've still got a y and a z, which is fine, okay, which is fine. But now I'm going to take a and c. So I'm going to take the negative 2y, or negative 2x, sorry, minus 4y minus 2z equals 20, or minus 20, sorry. And then I'm going to take the bottom one, which is 2x minus 3y minus 5z equaling 27. All right, minus 2z minus 20. So again, this part's going to go away. I'm going to have minus 7y minus 7z, and that's going to equal 7. Okay? Really, really, really nice upside. I'm going to divide everything by 7. I'm going to get negative y minus z equals 1. So now I'm down to negative 5y plus z equaling negative 25, negative y minus z equaling 1. So now, and I can do either substitution or elimination, whichever one's your preference. I'm looking at this plus z minus c, and elimination makes a lot of sense to me. So negative 6y equals negative 24. So after all that, y is going to equal 6. All right, and once I do that, wait, it's 24 divided by 6. I'm sorry. So it should be 24 divided by 6. Y should be 4. All right, write your steps so you don't make a mistake like I almost did. So y equals 4. So now work your way back. So negative 4 minus z equals 1. So add 4. So negative z equals 5. So z is going to equal negative 5. And then work your way all the way back to x, and you can figure out x however you want to. You can plug it in wherever you want. So if I say x plus 2 times 4 plus a negative 5 equals 10, so 2 plus 8 minus 5 equals 10, or x plus 8 minus 5 equals 10. So x plus 3 equals 10, so x is going to equal 7. So my final answer is going to be 7, 4, negative 5. So for letter B, same kind of idea. I'm looking at this middle row where I've got a negative x, okay? So I'm going to be using that. You know what? I could really go after whichever one I wanted because, you know, the y's, you've already got a 2, so you can multiply one of those by negative, or multiply the top and bottom one by negative 2, or I'm just going to stick with x. So if I take 3 times b and then go with a, so that's going to be like 3x plus y plus z. Then for 3b, we have negative 3x plus 6y minus 6z, and that's going to equal negative 9. Okay, wait, top one is 0. So that's, the x is going to go away. 7y minus 5z, not 7z, minus 5z equals negative 9. Then I'm going to do the whole thing again. I'm going to have 4b times c. So that's going to be negative 4x plus 8y minus 8z times negative 12. C, 4x minus y minus 3z equals 9. So that goes away. 7y minus 11z and minus 3. So now together, 7y minus 5z equals negative 9. 7y minus 11z equals negative 3. So then if I end up subtracting it, that goes away. Negative 5 minus a negative 11 is 6z. Negative 9 minus a negative 3 is actually going to be negative 6. So z is going to equal negative 1. If I work backwards, 7y minus 5 times negative 1 equals negative 9. So 7y plus 5 equals negative 9. So 7y will equal 14. Y is going to equal 2. Okay, then work all the way back to x. We know, so I'll go 3x plus 2. I'm taking this top one now. I'm taking a. Plus negative 1 equals 0. So 3x plus 2 minus 1 equals 0. So it should be plus 1 equals 0. Whoops, I made a slight mistake. My bad. Y should be negative 2, because that should be a negative 14, should be a negative 2. So that makes that a negative 2, which means it should be 3x minus 3 equals 0. So 3x equals 3, so x is going to equal 1. Okay, sorry about that. Okay, now I want to show a variation on this. We're going to show it. I'm going to show this is kind of a weird wrinkle, and I want to kind of show what happens. Right now, very, very messy. There's not a lot I can do. But what I'm going to try to do is combine A, B, and C, and I want you to see what happens. So let's just say I go 3 times A. I'm still trying to go after X, and negative 2 times B. So when I do that, it's going to be 12X minus 18Y plus 12Z equals 36. And negative 2B is going to be negative 12X plus 18Y minus 12Z equals negative 36. Okay, now please notice, when I add those two together, everything goes away. Okay, everything goes away. I am left with 0 equaling 0. That tells me that it is an infinitely many solution problem. Okay, that is an infinitely many solution problem. All right, so next one. Slight variation. Again, I'll take A and B again. So A and B again, so if I take 3A and I take negative 2B, so that'd be 18x plus 36y minus 24z, and 3 times 24 is going to be 72. Then down below, I have negative 18x. I will have negative 36y. I will have positive 24z, and that will equal negative 60. So then when I add those two together, I end up with nothing here equaling 12. And that's a false statement. That is never true. So that is my no solution situation. Okay? If you come talk to me with your graphing calculator, I can show you how to do this using a matrix. Basically, the short version is you take all of the coefficients, you take all of the numbers, okay, and that's all going to be multiplied by x, y, and z, okay, and that equals your solutions, 24, 30, 26, okay, and then when you do the inverse of this, you end up saying x, y, z equals 6, 12, and negative 8 inverse, 9, 18, negative 12, 4, 8, negative 7, and that's going to be multiplied by 24, 30, 36. Now, if you put this in a calculator, you're going to get an error because the error is going to tell you it's no solution. But come show me your calculator and I'll teach you how to do it. Okay, let's look at some word problems here. The first of three numbers, sum of three numbers is 20. Okay, so if we just call like A plus B plus C equals 20. All right, three numbers add up to 20. The second number is 4 times the first, and the sum of the first and third is 8. Write and solve a system of 3 linear equations to figure out the numbers. So C is going to be equal to 8 minus A. All right, so if I rewrite this, it's going to be A plus 4A plus 8 minus A equals 20. So 4A plus 8 equals 20. 4A equals 12. A equals 3. Well, if A equals 3, B is going to be 12 because it's 4 times 3. And then C is going to be equal to 5 because C is going to be 8 minus 3. Okay, this next one's going to be a doozy, so pay attention. 49,000 seats in a sports stadium. Tickets for the upper level sell for $25, middle level 30, ones in the bottom level are $35 each. Okay? The number of seats in the middle of bottom levels total together equals the number of seats in the upper level. When all the seats are sold for the event, the total revenue is $1,419,500. All right, so we've got upper plus middle plus lower is going to be 49,000. All right. The middle and lower combined add up to the upper. When everything is sold, 25 lower plus 30 middle plus 35, oh wait, I had that backed up, sorry. 35 lower, 25 upper, you don't pay more money to sit higher. So you want to basically solve that, okay? So let me rewrite this one so we're all kind of in the same order. So that's going to be lower plus middle plus upper is going to be that. So if I rewrite this second one and I write, lower plus middle minus upper equals 0. Okay, so upper or lower plus middle. Yep, there we go. Okay, so now if I kind of look and start combining what I can, so I'm looking at these two. All right, so if I go lower plus middle plus upper equals 49,000. If I go lower plus middle minus upper, I get 0. So I can only conclude that twice the lower plus twice the middle equals 49,000. So now, I've got that one. So now I'm going to take these two, and I'm going to multiply this thing by 25, okay? Because it's going to be pretty easy for me to work. So I've got 35 lower plus 30 times the middle plus 25 for the upper equals 1.419500. Then if I take 25L plus 25M minus 25 upper, that still equals 0. Okay, so I'm taking basically 25 times that because 0 is nice because it kind of works out everything. So that cancels out. So I get 60 lower plus 55 middle is going to be 1,419,500. So now I can kind of put these together. So I've got this one and I've got this one, and both of them deal with the lower and the middle. So what I'm going to do now is multiply that times a negative 30. Okay, so that's going to be a negative 60 lower plus a negative 60 middle, and that's going to be equal to negative 30 times 49,000. So that's going to be negative 1470000. So when I solve that, add those two things together, that cancels out. Negative 5m is going to be negative 5m, negative 50,500. So m is going to equal 10,100. Okay, so all that means is that there's 10,100 middle level seats. Okay, so now go back. I'm going all the way back to here. Okay, so 2 the larger plus 2 times 10,100 equals 49,000. So 2L plus 20,200. So 49,000 minus that, twice the L is going to be 28,8. And then divide that by 2. So my lower level is going to be 14,400. Okay, so then if you remember, middle and lower together equal upper. So add those two together to get the upper. 24,500 upper seats. There's my answer. Whew, that one's a beast. That was a lot to that. All right, that's another one where I can show you how to do that one on matrices. Let's look at this last one quick, then we'll talk about it. Mike knows he scored a total of 70 points for the season. His coach told him he scored 37 times. So he's got free throws, field goals, three-pointers. So he's scored 37 times. So free throws plus field goals plus three-pointers is 37 times. He knows he scored a total of 7 points. So 1 times x plus 2y plus 3 times z equals 70. The sum of his field goals and three-pointers equal twice the number of free throws minus 2. So y plus z equals 2x minus 2. All right, so I'm going to rewrite this. So it's going to be negative 2x plus y plus z equals negative 2. So now what I'm going to do is rewrite this as a matrix. So I'm going to have 1, 1, 1, 1, 2, 3, negative 2, 1, 1. And that's going to be multiplied by x, y, and z. And that's going to equal 37, 70, and negative 2. So now what I do then is I load that in the calculator, and I take the inverse, because the inverse is basically like saying take the opposite. I'm not going to show you how to take the opposite of a matrix because it's complicated. But I'm going to rewrite it as this. And I have to put the matrix in like this. I have to put it in this order and multiply it. And that will give me my answer. So when I run that through, I get x equals 13, I get y equals 65, and I get z equaling, I get x is 13, I get y is 15, and I get z equals 9. Okay, so check that, and you can always work through kind of like we did the other ones. But come talk to me if you have questions.